This is the follow-up video looking at applying our understanding of the 4 different quantum numbers. Before we start, I just wanted to remind us of our 4 different quantum numbers. The first one we need to remember is that n is the principal quantum number. And that can have positive integer values 1, 2, 3, etc. That is effectively what we've called the shell number. Then we have L, and L is the angular momentum. There are, for any given n number, the values of L are equal to n minus 1, but it can have values 0, 1, 2, 3, etc. So integers, but also 0 as a value. And then we've got the magnetic quantum number, ml. And the possible values of this range from minus L up to plus L in in integers, including 0. And then we have ms, magnetic spin, and that can have values of plus 1/2 or minus 1/2. So what actually the point of these? Well, these these quantum numbers describe all 4 of them together describe the pathway, movement, and designated orbital of an electron. So combined, we'll see later that they combine to give us the wave function, and from that the shape of our orbitals. So just have a quick look there one more time, just to remind ourselves of our 4 values here. So I'm going to take us through looking at n equals 1, n equals 2, and n equals 3 of all the possible values of our 4 quantum numbers, and seeing how that links with our understanding of the atom. So let's start at the bottom, and we'll see why we're doing that in a minute. And we're going to start with n equals 1. Well, if n equals 1, then there is only one possible value for L, and that value is 0. The reason it's 0 is the possible values of L are n minus 1, so 1 minus 1 equals 0. So our possible values for the magnetic quantum number are going to be 0. So remember that the possible values of the magnetic quantum number is minus L to plus L, going up in integers. So there is only one value of that, and the value of the magnetic quantum number is 0. But there are 2 possible states, for 2 possible magnetic spin states for this, plus 1/2 and minus 1/2. And if we think about our understanding of the subshell structure of an atom, well, that's going to be equal to our 1s orbital and the 2 electrons that can go into that, spin up and spin down. So let's have a look at n equals 2. So we're still going to have a value of L equals 0. Remember that the possible values of L are n minus 1, so in this case 2 minus 1, which means the possible values of L are 0 and 1. So for this first one here, then exactly as last time, we're going to have 2 possible ms values, plus 1, so plus 1/2 and minus 1/2, and that's equivalent to our 2s orbital with an electron spinning up and an electron spinning down. But we've also got a value of L equals 1. So this time we have 3 possible ml values. and our three possible ml values are +1, 0 and -1, and each of these have a possible quantum state or an ms of +1/2, -1/2, +1/2, -1/2 and so on. And actually, if we think about it, these are all degenerate orbitals, so they have the same energy, and that's equivalent to our 2p subshell. So L describes the p, or I should actually also say n equals 2. So n equals 2 describes the 2. The L having a value of 1 we call our p subshell. We have got three possible values of ml, which are our three orbitals here. We would actually call this the pz, px and py. So the pz has the value of 0, the px and py can be plus or -1. And then each of our possible magnetic spin numbers would be equivalent to our 2 electrons in each orbital. So we can see actually how these numbers have therefore been used in order to create our subshell structure. And for our values of n equals 2, we can fit in total 1, 2, 3, 4, 5, 6, 7, 8, which is our basic understanding of how the structure of the atom works. If we have a look, and I might run out of space doing this, but if we have a look at n equals 3, then for n equals 3, we have got a potential value of L of 0, we've got a potential value of L of 1, and this time we've also got a value of 2. The value for ml for this, there's only one option for this, and that's going to be 0. The ml values for L equals 1, as we did on the previous one, +1, 0 and -1, and the ml values for 2, this time there are 5 values. Remember, it's from plus L in integers down to -L. So +2, +1, 0, -1, -2. How did we get at that? We take the greatest positive value of L, which is +2, and go down in integers down to -2. Each of these have got a possible magnetic spin number of +1/2 or -1/2. So the ms values for this one is +1/2, -1/2. So we've got two possible ms values for each of these. And actually that then hopefully makes us understand how we arrive at 5 orbitals for the d subshell. So what would be worth having a look at now is seeing if you can work out all of the possible values for our quantum numbers for the value of n equals 4. Thank you very much.